Greetings everyone. In this video, I am going to show how to use Automatic1111 Web UI for stable diffusion tasks on RunPod IO like you are using it on your computer. I will cover many topics such as how to upload and download files quickly, how to delete directories, how to install and run extensions, how to quickly download and use custom models, how to do DreamBooth training on Stable Diffusion 1.5 or 2.1 versions, how to do fine-tuning via DreamBooth extension, how to do textual inversion training. I will also explain how their pricing system works, how you can use bidding, how you can transfer files from pod to pod or from computer to pod and vice versa, how you can install custom other scripts such as famous Kohya graphical user interface. I will also demonstrate how you can use new famous ControlNet on RunPod IO. So why RunPod IO? Because their system charges you based on per minute and they have great Discord support. They are also easier to use with the tools they have, but still, if you are interested in free cloud services for stable diffusion, I have two great tutorials for Google Colab. The first one is this one and the second one is this one. And if you don't know how to use Automatic1111 Web UI, if you don't know what is stable diffusion, what is Automatic1111 Web UI, I have great tutorial series for them. For example, you can begin with watching video and you can check out the other videos in this playlist. So let's begin the Grandmaster RunPod IO tutorial by signing up a new account. Click the sign up button. For sign up, I will use my Google account. You can also enter your email and password if you wish. Choose your account to sign up. Click I have read and agreed the RunPod terms and services. Click continue. And yes, we are ready to start. First of all, you need to charge some credits to start using the pods. Click your balance from here, as you can see in the right top menu. Then it will show your available balance. From here, you can pay with a card. You can change the amount that you want to charge. To have automatic payments, you can add a card. They also allow you to pay with a crypto. Just click this icon. They also show recent transactions, recent charges, and everything is very transparent. Okay, now I have logged in my account where I have my credits. Now we can start using our pods. To do that, go to the Browse Servers tab in here, and in here you will see the available servers. If you are going to do training, then I suggest you to get minimum 24 GB VRAM having server, because currently the latest officially released xformers is not working very well for training. They have a nightly version that works well, but for training we won't use xformers, and if you are not going to use xformers, then you should get minimum 24 GB VRAM having server. I find that RTX A5000 is very decent GPU with a lower price. As you can see, it is only $0.32 per hour. So I am going to deploy RTX A5000 GPU. When you click deploy icon, this interface will appear to you. So in this interface, you should select your template. There are many templates. When you type stable diffusion, you see there are two very popular templates for stable diffusion: RunPod Stable Diffusion 1.5 and RunPod Stable Diffusion 2.1. I will start both of them and I will start doing training both of them simultaneously. So let's begin with RunPod Stable Diffusion 1.5 as a template. So it will also download the official 1.5 version when it starts. In here it shows us the other features. They are very decent. The temporary disk is the disk where the operating system will run. You don't need to increase this. And the persistent volume. Now this is really important. The persistent volume will remain as long as you don't delete your pod. So when you close your pod, it will remain as it is. It is like your hard drive. It is persistent. Everything you have generated, you have downloaded will remain there. So this should be a sufficient amount of disk space based on your needs. I am going to set it as 100, and when you set it, it will increase your minute credit spending. So when you hover your mouse over this icon, it shows that 0.10 per gigabyte per month for total disk on running pods, 0.20 per gigabyte per month for volumes on exited pods. I know that this may be sounding confusing in the beginning, so I have prepared an example for you which I will explain step by step. So we have 105 gigabytes while running. Why? Persistent volume is 100 gigabytes and temporary disk is 5 gigabytes. So while running, we are going to spend like this. Let's say our pod did run 75 minutes. So 105 multiplied with 0.1, which is the per gigabyte price for per month. In per month, how many days there are? 30 days. So we are dividing it with 30 days. In a day, how many hours there are? 24 hours. So we are dividing it with 24 hours. In an hour, how many minutes there are? There are 60 minutes. So this is the price of per minute running, and since we are running 75 minutes, it is going to take total $0.018 from our credit. You can also copy this, open your calculator with typing calculator in your search bar, paste it and hit enter, and you will get the result like this, as you can see. So in the below, I am giving example of pod when it is not running. When the pod is not running, we are going to use 100 gigabyte persistent volume, and let's say our pod did remain not running for 2 days. So when pod is not running, the price is for per gigabyte per month $0.20. So since we have 100 gigabytes, 100 multiplied with 0.2, then let's delete this to not have more confusion. Then in a month we have 30 days and we are going to use 2 days. So this will be our spending. So you can also open the calculator and copy paste it, hit enter, and you will get the price. So this part is the price of 1 day offline for your 100 gigabytes having pod. And since it will be offline for 2 days, this is the credit that we are going to use. The very important thing is that these credits will be deducted from your account per minute. So if you keep using RunPod IO service for 10 minutes, you will be charged for 10 minutes. So if it remains offline for 10 minutes, then you will be charged for 10 minutes. It is not like taking your credits for per day, for per hour, or for per month. It is using your credits for every minute. When you hover your mouse over encrypt volume, you will see the message encrypted volumes provide better data security but will incur a performance penalty and cannot be resized later. So unless you need this, don't check this box. Start with Jupyter Notebook. This will make your life much easier. And this is the price per hour for our GPU. So this price will be added these volume prices as well. After you click the deploy button, you will see an interface like this. You can go to the My Pods section and you will see on-demand community cloud is being prepared. When I click in here, you see it is showing me the messages of the pod that is being prepared, what is happening on the pod. And once it becomes ready, we will see connect button in here. So it is initializing the pod with the necessary installation, and the pod is now ready and it is running. Now I will start ST 2.1 version pod simultaneously. To do that, I am clicking browse servers, and when you open browse servers tab, you will see in the right tab how much credits you are spending right now, because currently my other pod is running, as you can see in my pods tab. So let's return back to browse servers, and in here there are several options. So you see there are 1 GPU pods, 2 GPU pods, large pods, 4 GPU, or X large pods, 8 GPUs. So if you need multiple GPUs, then you can filter them with this. Also in each pod, you will see their location, their available upload and download speeds, their available disks, and other things. Choosing a less used pod is better, because if your previous pod is fully used, then you won't be able to get a GPU on that pod. So what happens then? Then to use your existing files, you need to compose a new pod and transfer your files. So availability is really important when choosing your pod. If you choose highly preferred pod, then you will have lesser time to get it, and it will make things harder for you. So based on this fact, you should choose your pod. So for the ST 2.1 version, I am going to pick another RTX A5000. When you click more RTX A5000, it displays you other locations as well. You see the upload and download speeds changes, the available space changes. More available space probably means that it is being used lesser. So for Canada server, it looks like it is not very much preferred, this particular server. So there is also Norway server. You see it has great upload and download speeds. It has decent hard drive space as well. So it is probably also not very much used. However, this is expensive than others. So I think I will go with this Canada server. Its speeds are also decent. Click deploy. There is one more thing as well that I need to explain. Community cloud. So what does community cloud means? That in the community cloud section, you will be able to bid for shared servers. All of the servers are shared, but this is kind of that you bid, and if someone overbids you, they get your GPU. So in here, you see the prices will be lower. When I click RTX A5000, select, and then I click continue. So you see currently this is selected, RunPod Stable Diffusion 1.5. I can also change it from this template. Don't forget to change template. When I click continue, you see now I am getting pricing summary and advanced. When I click advanced, it will allow me to bid for a spot. So you see the current bid is 0.198. When I bid this, I will overbid the other person who has bid lesser than this. So I am going to get his GPU if there are no available other GPUs. So let's say we did bid like this and we started our RunPod. So someone else comes and bids 0.2 and they will get our GPU. Then our pod will not have any GPU to do inference or training, and our training will be also halted. So be careful with this. If you are not going to do training, if you are only going to do image generation, then you can go with this option and spend lesser. The running this cost and exited this cost also slightly changes. You can recalculate the costs. So this is how you do bidding, and this is how you use community cloud servers. Since I am going to do training, I am going to use on-demand server, and I am going to pick on-demand server from here, this Canada server. Let's check again. Yes, I am going to use this Canada server because it has the most available disk space. Therefore, I am assuming that it is being used lesser than others. Click deploy, and we have selected RunPod Stable Diffusion 2.1 version. Let's set our persistent volume as 100 GB, and let's also deploy it. So it will get deployed. When I click my pods, I will see them in here. Okay, when you go your my pods, it is going to show you if there will be a maintenance or not. So you should be careful with this maintenance. It says that it will start at this local time. Therefore, I think I will delete this pod. So I will just click stop pod, and then I will delete it. So when you stop your pod, it will remain as it is. However, if you click this terminate, then the pod will be permanently deleted and you won't be able to recover or access any of your data. So now it is gone. Let's go back to the Browse Servers tab, and let's pick another server from here. Maybe that is why it was being lesser used. So I will pick this one. Okay, 2.1 version, 100 GB. Let's deploy. Let's go to the my pods, and it is being deployed. The first one we started is running. The other one is being initialized, and this is my per hour using credits right now. Okay, let's connect our first pod. To connect our first pod, I am clicking my pods. Let's refresh. So you will see the interface as it is. Okay, I am clicking here. It will open the interface. When you click logs, it will show you the logs screen. This is really important to debug the errors that you might encounter. So it started with xformers, with workspace 1.5 pruned, EMA only ckpt file. Actually, this is not the best ckpt file for training, so I will download the best one. and it is running on xformers 0.0.16. This xformers is not compatible with DreamBooth training or textual inversion training, unfortunately. So we won't use xformers during training, and the other things are also displayed here. When you click system logs, it will also show you the system logs. When you click this refresh icon, it will refresh, and when you click this X, it will close it. So let's click connect, and I will connect it via Jupyter Lab, which will make our life much easier. Okay, so our Jupyter has started like this. The first thing that I am going to show you is how to change starting command line arguments. To change them, I am zooming it for you to see easier. There is web UI-user.sh. So this is the file where the command line arguments are provided. You see it is starting with default port 3000. It is starting with xformers. The default ckpt is provided like this. And there is a listen and enable insecure access. So if you wonder what are these arguments are doing, there is a wiki page of Automatic1111 Web UI, and you can search for the commands by copying and pasting them, and it will show you launch Gradio with 000 as server name, allowing to respond network requests. Actually, I am going to also add share to be able to use it from my browser like this. And enable insecure extension access means that we will be able to install extensions. Make sure that these commands are already enabled, otherwise you won't be able to install extensions. And I think we are ready. I will also change the port to not get conflicted with any of the initial starting. Just save. When you save, you will see in the bottom saving completed. Then go to the running terminals and kernels, shut down all of the running terminals, and then go back to the file browser. Make sure that you are inside Stable Diffusion Web UI folder. Then start a terminal. When you start a terminal, it will start with the folder that you are currently in. You see it is the same as the folder that we are in, and in here we will use relauncher.py. To do that, just type Python, and I will copy paste the name relauncher.py, hit enter, and it will restart our web UI with the newest set command line arguments. We should be able to see them in here. Yes, we are seeing -- port 3010 xformers. So with this way, you can also start multiple instances of web UI. If you are a professional, then you can do that, but if you are not, I don't suggest you to do that. Now we can access it from this public URL. This public URL is currently not secured by a password. You can also add a password in here, I think. Let me show you. Yes, you can also set out username and password. However, if you are not giving this URL to anyone, then it should be safe. As you can see, our interface is started. Let's start with typing a simple prompt and see what happens. Okay, I have prepared my prompt. I hit generate. And in my pods, now you will see the GPU memory used is being increased. GPU utilization will also increase as it generates the images. And the image is already generated. Let's set the batch size as 8 and batch count as 100. And let's see how it is using our GPU. So let's hit the refresh. So it is showing like 10 seconds ago. Okay, now you see the GPU utilization is 100%. GPU memory used is still significantly low because it is using also xformers, even though we are generating images as batches with 8 as batch size. So in each time it will generate 8 images. So where are these files are being saved, and how can I see if any error occurs? You see in the my pods, just click the logs and you will see all of the logs here. This is really important to debug the logs. And in here in the terminal window, you will see what is happening. So how can you open the terminal? To open the terminal, go to the running terminals and kernels, and let's say I have closed the terminal. I double click the terminal and it will show me the terminal as here. As you can see in here, this is equal to the terminal that we have on our computer when we are running it locally on our computer. This is the IT per second. However, since we are generating 8 images at a time, it is actually over 24 IT per second. You need to multiply this with 8. Okay, let's hit the interrupt. Now I will install the DreamBooth extension. To do that, go to the extensions tab. go to the available, hit load from, search DreamBooth, hit install. Meanwhile, my 2.1 version terminal is also spending my time, my credits, so I will just stop it. So when you click stop pod, you are going to get this message. You should read it and understand it. Okay, stop it pod. Basically, what does it say is that all of the things that is not saved on your workspace will be lost. So whatever you have in your workspace will be saved. Okay, let's see the status of the installation. Okay, it says that install it into workspace, Stable Diffusion Web UI extensions, SD DreamBooth extension. Now I will restart my terminal, because when you first time install DreamBooth, you really need to restart terminal so that it can install the necessary dependencies. So I'm going to do terminal stop, shut down all terminals. Then I am going to Stable Diffusion Web UI folder, and in here I will open a new terminal. Same as before, I will type Python and relauncher.py and hit enter. So the web UI has been restarted, and now we got a new link. Let's copy and paste it. Meanwhile, it is being loaded. Let's check out the generated images. So they are saved in the outputs folder, in the text to image images folder, and yes, they are in here. So how to download them? You can download them one by one. Right click and download, then it will download like this. You can alternatively right click and download current folder as an archive. It will first make archive and it will download all of the images like this. It is a decent speed and it has downloaded all of these images, 121 files so far. Okay, the interface has been reloaded, and now we are seeing the DreamBooth extension. When we go to the extension tab, check for updates, we should see the latest version in here. Actually, it says that it is behind, so let's click apply and restart UI. And once we do that, we get an error. It is relaunching in 2 seconds. Okay, when relaunching, we are getting port error because the previous one was crashed. So what I'm going to do is I will shut down all of the terminals, go back to the file browser. In the first installation, you may encounter such errors. Go to the web UI user.sh file and change the port here, and then go to the terminal tab, open a new terminal like this and type Python relauncher.py. It will restart. And when restarting, now it is showing us the DreamBooth revision and the SD Web UI revision like this. I will just start training. Okay, it has been restarted. Let's open the new URL. Okay, currently it is selected as 1.5 PRUNet EMA only ckpt. And in the DreamBooth tab, when we are going to generate a new training model, this is only available model. However, 1.5 PRUNet ckpt is better than EMA only for training. Therefore, I am going to download this ckpt file. So how am I going to download it? You see there is a download button in here. I am right clicking and copying link address. But before doing that, let's start a new terminal. To do that, I am going to right click new plus icon here. It will open a new launcher. Hit terminal. For fast download, I am going to use RunPodCTL. The RunPodCTL allows us to quickly download or upload files through our pods to pods or from Windows to pods and vice versa. There are different versions. I am going to install the Linux one on my RunPod. So I am selecting it like this and copying it. Then in my terminal, I am pasting it with Ctrl V and I am hitting enter. It will install the latest RunPodCTL. After this command, type RunPodCTL, hit enter, and you should get a message like this. That means that it has been successfully installed or it was already installed. Now, how are we going to download this PRUNet ckpt file? To download it, first enter where you want to download, which is inside models, inside Stable Diffusion, and in here where we want to download our model file. Then I am going to click this plus new launcher, launch a new terminal, and in this new terminal, this is the folder where we are right now. Now for downloading, type wget and copy this URL, paste it, hit enter, and it will get downloaded inside this folder. By the way, RunPodCTL is not necessary to download this file, but we will use it to send data and get data from RunPod to our computer, or from computer to RunPod, or from RunPod to RunPod. This wget is a Unix command, and also alternative of it is available on Windows as well. So with this wget command, you can quickly download files into your RunPod folders like this. So you see currently it is downloading with 90 megabytes per second, which is pretty decent speed. Okay, the download has been completed and now the file is located in here. Then what are we going to do is hit refresh button here, and now I can see the 1.5 per node ckpt as well. This is the way to download models from Hugging Face or wherever they are hosted. If you can get direct link of it, I will show examples, don't worry. So now I will start DreamBooth training with the best possible settings. First, let's switch to 1.5 per node ckpt. This is not necessary, but I'm not being sure that it is working as expected, so I am making sure I have selected the target model in here as well. So it has been loaded. If it doesn't get loaded, you should check the terminal window. It is running on here. It will show what is happening, and you can also check the logs window in here. It will show what is happening. Okay, now let's give a name to our training. Let's say test SD15 and check the source point. So you see it is not seeing my latest checkpoint. I am clicking refresh and I am checking the latest checkpoint. This is very good to teach faces. 1.5 per node ckpt. The 512x model is selected and hit create model. I am not changing other parameters because optimal parameters are currently selected. These are more like experimental things or things that for more professional people. And in the terminal, you see it is downloading the necessary files right now. That is why it is waiting. Okay, it says that checkpoint successfully extracted. So the model has been generated. However, as you can see, the interface is frozen. Unfortunately, this is a problem of Gradio. So what are we going to do is we will refresh, reload this page, and now it says no interface is running. It looks like the interface has been terminated unexpectedly. And what do we see in the terminal in here? In the system logs, okay, it doesn't show anything, and it doesn't show anything in here either. So let's check out our terminals. Terminal 1, which is our main terminal, and yes, it is not showing. So what can we do? We need to restart. To restart, I will shut down all terminals and I will follow the same procedure. Open terminal. However, currently we are inside model Stable Diffusion, so it won't work. We need to move to the parent folder. To moving parent folder, I am closing this terminal, going to the folders tab. I am navigating like this, opening a new terminal, Python relauncher.py. And in my pod, currently GPU memory usage is only 11%, so it is good, which means that no other terminal or instance of Web UI is running. Also, there are some warning messages here. I think we could ignore them. Okay, it has started. I am opening this URL. I am going DreamBooth tab. And now I will select my model because I already created it and it is selected. Let's set up the settings. Okay, I won't pick this checkbox because it is usually causing me problems. How many steps per image? I am going to use 12 images and I am going to train up to 200 epochs. I will save model for every 10 epoch. Be careful with this because each save will take about 5 GB space, and with every 10 epoch it is going to make 20 saves, so it is going to take all of my hard drive. So I think I will make this up to 180 or 160. This should be sufficient. If you don't know what are these parameters, how am I setting them, I have an excellent DreamBooth tutorial on my YouTube channel. You should watch this definitely to learn more about DreamBooth training. Okay, the batch size is 1, gradient accumulation steps are 1, class batch size, which will determine how many images at a time that I want to be generated for classification images, not related to training. I will set this as 16 because this graphic card has huge VRAM, but if we get error I will reduce it. Set gradients to none when zeroing, okay, correct. I'm going to use half learning rate. I am going to use sanity prompt as photo of OHWX man by Tomer Hanuka. I will explain what are these for. Actually, I am explaining what are these for in this tutorial with details. This is for checking the overtrain it or not. And in here, I am going to use EMMA. This will improve my training success rate, and I have 24 GB VRAM. I will use 8-bit add-on. I am going to use mixed precision, and I am going to use FP16 because this BF16 is not supported by all graphic cards. It is supported by RTX 2000 series or 3000 series. I am not sure about this card as well. So FP16 is our most safe option for every cards. I am not going to use xformers. This is important because the current xformers is not supporting the DreamBooth training or textual inversion training. It is, you see, xformers 0016. I think it will become compatible with xformers 0017 when it is officially released. Currently, nightly version is supporting as far as I know. Cache latence, yes, it will improve speed train unit. Okay, these are the optimal settings actually, so no need to change them. And in here, concepts. Okay, first we need to upload our training dataset. To do that, go to the Stable Diffusion Web UI folder or workspace, doesn't matter. I will upload them to workspace. In here, create new folder, training dataset. I have named the folder like this. Enter inside folder and click upload files. Select the files from your computer. Since I don't have many files currently, I am going to use this method, and you see I have only 9 images which are pretty close shots, no same background, no same clothes. As you can see, I am all explaining what's a good training dataset in this video, and they are getting uploaded. We could also use RunPodCTL. However, since there isn't many files, I am using this methodology for this task, and our training dataset is ready. Okay, now we need to give the path of it. To give the path of it, go back to the workspace like this, right click, copy path, paste it like this, and put a backslash to the beginning of it. And where we want regularization images to be generated, I am copy pasting like this, and I will type classification images. Okay, file words. For training phases, I am not using file words. It is more likely needed to fine-tune your model with lots of tokens and lots of good images. If you wonder how file words are working, in this short video I am explaining how file words are actually working. So I'm just skipping file words and I am going to prompts. So our instance prompt will be ohwx man. ohwx is our rare token and man is our class. Class prompt will be photo of man, since I am teaching a face of a man. Sample prompt will be simply photo of ohwx man. I am not going to set a negative prompt or other things. How many classification regularization images we want for per training image? I have 9 training images and I want 50 for per image. This is actually a debated topic. How many is good is not precise. In the official DreamBooth paper, the authors have used 200, so you can also try with 100 like this as well. Okay, then go to the saving tab, generate a ckpt file when saving during training. So we will be able to generate checkpoints for every 10 epochs, and then we will be able to compare them to see which one of the checkpoint is performing best, which one of the checkpoint has learned our subject best, and with this way you can avoid overtraining. And once you are ready, click save settings and hit train. First it will start with generating class images. In my pod I will say GPU utilization and memory used. Okay, it says that exception training model, no executable, batch size found reached 0. Why we got this error? Because we did set the classification images batch size pretty big. If you make it like, let's say 6 and try again, and now I am seeing that it is generating 6 images at a time. The IT is pretty low actually, only 12, because we need to multiply this with 6. And we are seeing the images are being generated. They will be saved in workspace classification images directory like this. If you have previously generated images on your computer, then you can alternatively upload them. For uploading them, I will install RunPodCTL on my Windows. To do that, I am going to run this command on my Windows PowerShell. Type PowerShell, right click and hit enter. Okay, the installation has been completed. The RunPodCTL is now available on my command prompt. Let's see RunPodCTL, and now I am seeing it. So I have previously generated 2400 images on my hard drive. I am going to share this with RunPodCTL to download them in RunPod. Alternatively, you can use upload methodology as well. It also works, but for bigger files, RunPodCTL is better. So for sharing the folder, type RunPodCTL send and the folder path like this. Getting the folder path easier, copy the folder path from here, paste it into the notepad like this, put quotation marks to the beginning and end, and type in your CMD. I will show from beginning once again. Open CMD, type RunPodCTL send, and paste the path like this, and it will prepare like it. It says that photo of man zip already exists because in another CMD window we used that. So I need to delete this file. Okay, this zip file is generated inside local disk C users and my username directory. I am just going to delete it and I will run the command once again. It will quickly prepare all of the files, and now share link is generated. I am copying this, selecting it, Ctrl C, or select it, right click from here and copy. Then go back to your Jupyter Lab where your RunPod is running, and in here I will make a new folder like this, ready class. I will enter inside ready class folder, then I will open a new terminal like this, and I will paste the command. You see RunPodCTL receive the URL it has generated. Hit enter. It will connect to my computer and it will start downloading all of the files very quickly. So this is how you can upload files from your computer to the remote RunPod. The same thing applies to the RunPod to RunPod. So this is all vice versa. RunPod to computer, RunPod to RunPod, computer to RunPod. You can send and receive files like this. This is of course totally depends on my upload speed. So when I open my task manager, I see that it is using all of my available upload speed like this. This is pretty useful and convenient. Instead of generating new classification images each time, which uses your GPU time and consumes your credits, you can prepare them on your computer and then quickly upload them to your RunPod. You can also upload them to any hosting website or other places that has better upload speed and download them with the wget command as I have shown to download ckpt file. RunPodCTL is extremely useful to upload and download files as you can see. Okay, 2400 photo of man, the classification regularization images upload have been completed. Now I see that it is uploaded as a zip here. I need to extract them oh, it has automatically extracted as you can see. After refresh, now they are here. So what am I going to do is I will cancel training and I will give this folder. So I will just keep image generation. So it has been cancelled. Let's give the new folder. In concepts, type here new folder name and click save settings. And okay, looks like the train button is not appeared. So what we need to do is we need to refresh, reload. Okay, reloaded. Go to the DreamBooth, select the model, hit load settings, verify the settings are properly loaded. Okay, this is not being saved, so you should uncheck it. Okay, all settings are looking good and click train. Now it won't generate any new classification regularization images because we already provided. We can see that in the terminal window in here. So you see it is processing the uploaded photo of man images. Then it is going to cache the classification images with caching latents. Okay, the training has started. It has a pretty good speed as you can see. It is supposed to do 180 epochs in less than 15 minutes. However, this will take a little bit more time because it will generate ckpts during the training. We can also watch the training here. However, you may get disconnected from Gradio interface. You can just watch the command line interface from here and know the status of the training if that happens. Okay, 10 epochs have been completed, so it started generating the initial images, as you can see. It also generated a checkpoint. Where can we see the checkpoint? Go to the workspace, go to the Stable Diffusion Web UI, go to the models folder, go to the Stable Diffusion folder, and in here you will see our training name. Go inside that folder, and now we can see the checkpoints being generated. Then we will test each one of them with xiplot and see how they are performing. So if you want to see the generated samples during training, go to the models folder, go to the DreamBooth folder, go to your training name it folder, and in here you will see samples. So these are the samples being generated during training, and when you click the txt file, you will see which prompt was used to generate this image. When you double click the image, it will open the image like this. So far it is not like me at the moment. When you go to the My Pods, you can see the GPU utilization and GPU memory being used. The GPU memory is almost full because we are using EMA and we are not using xformers. Because in the settings tab, we checked the use EMA, and in the memory attention, we didn't use xformers. And these two are heavily increasing the memory usage. Also, we didn't check the gradient checkpointing. This also reduces the VRAM usage. However, if you have sufficient amount of VRAM, you shouldn't check this as well. Okay, even after 130 epochs, it is still not learning, even though it shows a good loss rate. That means that there is a bug currently with DreamBooth extension. Therefore, I have cancelled the training. Now I will delete the folder to open a space. Right click folder, delete it. It says that it is not empty, so you can't delete it. However, we can. Now I will show you how to do it. Click new, open a new terminal, type rm-r and the directory name test sd15. It will iteratively delete all of the files and the folder. After we refresh, it is gone. Now I will figure out the problem and show you the working settings and setup. So I have figured out the problem, and the problem was exactly as I have guessed. It was using xformers, even though we didn't select use xformers. In the settings, we had used memory attention default. However, it was still using xformers. So what did I do to fix this problem? It is simple. I have opened the web UI user.sh file, and I have removed the -xformers from command line arguments. I have restarted my web UI. Then I have composed a new training with the exactly same parameters, and it did work very well. The training has been completed. So let's download the samples and check them out on our computer. To download the folder of samples, I will use RunPodCTL command. So what I need to do is I will enter the samples folders. So to do that, go to the models folder, go to the DreamBooth, go to the training folder name. So the samples are located here. Open a new command, terminal, write RunPodCTL send samples, which is the folder name, and it will zip the samples folder and generate a receive command. Copy it with Ctrl+C. First, I need to add the path of RunPodCTL into my environment. So the currently RunPodCTL exe is located inside my user folder. Go to the users and your username, and I will copy the RunPod YAML and RunPodCTL exe file, copy them. Then I will make a new folder in my C drive as RunPod exe, paste them here. Then in the search bar, search for environment. It will open edit environment variables like here, and in here I am going to add a path variable for system variables. So go to the path, click edit, and in here click browse. Select the folder where you have copy pasted, which is inside C drive, RunPod exe, click OK. Now the RunPod exe is registered in my path, click OK, click OK, click OK. And now RunPod exe should be available to call from everywhere. Where I want to download the files inside my pictures, inside test samples. I type cmd here. So currently this is where I am. Now I will copy and paste this command into my cmd window. And yes, it is running as expected, and the files are being copied into my folder. and then they are automatically extracted with the folder name. So in here we are able to see the generated sample images. I can say that after 800 steps it started to resemble me, and we have totally trained it for 160 epochs, 3200 steps. We can see the examples here. Okay, this is pretty much like me. So with good prompting, I think we can get good results. So let's try all of the checkpoints to see which one is working best. How are we going to do that? We are going to do that with text to image tab, and in here we are going to use XYZ plot. Okay, it didn't appear. Let's refresh. Oh, looks like our instance is closed. So I will restart. So before restarting, make sure that you have closed all of the running terminals, and I will also close all of the open tabs. Okay, all of the tabs and terminals are closed. Okay, Web UI is restarted. Let's open it. Okay, now we can also see the checkpoints in here, so you can test particularly one of them, but I am going to do XYZ plot test. But before that, let's decide our testing prompt. So I am going to make my tests on 2200 step checkpoint. I'm going to select it from here. First, let's see the raw prompt, OHWX-man. Okay, this is the raw prompt and it looks pretty decent. This is the training dataset. You see, it looks pretty decent, but it looks like have some memorization. Actually, not exactly memorization. The code is similar, but not exactly same. Okay, while doing testing, my Web UI has been killed. So I have checked the terminal to see the message. So you should be careful if some error happens. Make sure to check the terminal to see what is happening in the behind the scenes. And now it is not able to restart. Therefore, I will close all of the terminals and start with a different port. To do that, you need to go to the terminals tab, shut down all, and change the WebUI user.sh file, change the port from here, save and restart. Okay, I got a simple prompt like this photo of OHWX-man 1.2 emphasis. You can learn emphasis from wiki page of Automatic1111. Just pause the video and read here if you don't know. And digital painting ArtStation masterpiece. I don't have any negative prompts. The picture is not exactly like me, so now we are ready to do test and see if model is trained enough. If it is not trained enough, then go to the DreamBooth tab, select the model, load settings, and continue training. It will continue training for the number of steps that you have defined in here. Okay, I started continue training and it will start from this model revision, which means it will start from 3200 steps and it will continue to do training for number of epochs that we have defined here. However, my Gradio is crashed once again and I am able to see the continuing training from here. Now let's test the current checkpoints and see whether they are trained enough or not, and decide upon that to continue training or not. However, since my Gradio is crashed, I have to restart the terminal because there is no way to cancel the training right now. Let's also yes, no way. Okay, I did a restart. So how are we going to test different checkpoints, prompt emphasis, and CFG values? Go to the bottom, pick X, Y, Z plot, and in here you see there are different type of parameters. So first parameter will be checkpoint name. When you click this icon, it will paste the available checkpoints. I am going to start picking from 1600 steps, which means 80 epochs for me. It depends on your training dataset size, and I will test the remaining as well, like this. It is also displaying their calculated hash value. Okay, as a second thing, I am going to test prompt strength. To do that, I am going to use prompt SR. So I am going to give this any keyword like PRSR. So the first value here will be PRSR. Then I will type the prompt strings like 1.1, 1.2, 1.3. Let's also try 1.0, 1.4, 1.5, 1.6, and 1.7. Okay, as a third comparison thing, I am going to test CFG value. So for CFG values, I am going to test 7 7.5, 8, 8.5, 9, 9.5, and 10. If you keep -1 for seeds, then you won't be able to compare them very well, so do not check this checkbox. So it will use same seed for all of the comparisons, and then when you click generate, it will process all of them. You can see the process in the command line interface. Now meanwhile this is running, I will start my 2.1 version RunPod as well. Okay, it says that there is no available GPU for this RunPod right now, so I can start it without a GPU and transfer my files with RunPodCTL. However, I do not have any files on it, so I will just delete it because I didn't even start it yet, and I will start a new one. Okay, I am going to use this one. Select the template from here. I will pick Stable Diffusion 2.1 version. I will start with 100 gigabytes. Deploy my pods. It is being initialized, and my other pod is currently working with this kind of IT. By the way, xformers is still not enabled right now, so if you enable it, this will become even faster, but for training, make sure that you have disabled it, and the images are being generated in here. We will download all of them and check all of them later. Okay, 2.1 version is being generated and getting ready. Okay, 2.1 is now ready. Just click connect to the Jupyter. Okay, it says that it cannot connect yet, so it is probably still not ready. Let's wait, try again. Okay, let's refresh the page. Maybe the URL is incorrect. Yes, after the refresh, I think it is fixed or it is just started. So just be patient a little bit. It is getting loaded. And yes, 2.1 version is started. It is exactly same as the previous one. We are editing the command line arguments here. I will add --share so I can use it as I want. And I will also remove xformers because it is preventing training. I will set the port as 3001. Save it. Then there is no open terminals. Let's open a new launcher. Terminal. Python relauncher.py. Our comparison on SD 1.5 trained models are continuing. Okay, 2.1 RunPod is ready. Let's start it. Okay, currently selected model is 2.1 version. Let's test it. Okay, I have written my prompt. The output resolution is 768 and 768. Looks like we got a problem. It says that a tensor with all nonce was produced in unit. So we need to add no half command to the command line because with this graphic card otherwise it won't work. So let's go back to the RunPod, open the web UI -user-sh. So for SD 2.1 version, make sure that you are using these command line arguments. These may be necessary for some of the custom models as well. So check the messages that you see in here. This message should be available also in the terminal window. Yes, you can also see the error in here as well. So I will close the terminal and restart it. Currently, I am spending $0.669 per hour. My both of the RunPods are running right now. Okay, it looks like I have mistyped the --precision. So it says that argument precision expected one argument. I will just fix it quickly. To fix it, I am opening the file and I am setting --precision as full, saving it and restarting. Make sure that you only have one active running terminal, otherwise other terminals will also consume your VRAM memory. You can also see the VRAM memory usage in your MyPods tab, and you can see the logs from here. This is really important to debug the errors. Okay, it is started with these command line arguments exactly like this. Let's open the Gradio window. Okay, let's hit generate with our written prompt, and it is getting generated. And we got our tank image. Now I will install the extension, same exactly as I have did. Okay, 2.1 version is ready with DreamBooth now. Go to the DreamBooth tab, make a new model. I will name as test, select the source checkpoint, uncheck 512 model, hit create. When the first time you click hit create, it is downloading the necessary files, same as before, because this is a new RunPod, so they are not connected. This is a fresh installation, and checkpoint successfully extracted, so it is ready. Okay, we didn't get any error, so we can continue. So for 2.1 version, usually you need more epochs. So I will set this as 300. However, now it will also use more space due to more epochs. So I need to reduce save model frequency. I think I will save it for every 20 epochs. Batch size 1, gradient accumulation 1, class batch size will be 4. I am not going to set gradient checkpointing. You can also leave it as default learning rate. This would make it learn faster. However, it may also not learn very well, or it may get overtrained quickly. So I will make this as 1, but you can also leave it as default. So the other things are same. Now with 2.1 version, I don't know if 24 GB will be enough without xformers when we use Emma, so I will test it. Okay, it says, let's make it like this. Actually, we should click performance wizard, so it will set the optimal ones for us. Okay, I am leaving the settings like this. Let's also set the memory attention as default, and let's see if it will work. By the way, we also need to re-upload our training images, and these training images have to be 768 pixels because this model is 768 pixels model. So to upload them, I am following just the same things. Here my 768 pixel images. I'm just going to use drag and drop, but you can use RunPodCTL as well as just I have displayed. Okay, they are ready. So I am right clicking, copy path, paste it, adding a backslash to the beginning. Copy this and let's say class 786. All other settings are same. OHWX man, photo of man, photo of OHWX man, and I will use only 12 images because I want training to start quickly, but you should use bigger number. I am checking generate ckpt during the checkpoints, click save settings and hit train. So it will start with generating class images. So for each image we are generating 12. Okay, we got an error, therefore we need to decrease the class page size. Let's hit train again. Okay, looks like our Gradio is killed, therefore it has to be restarted. You may get these errors. Okay, during restart it is throwing error because port is still being in used. So I am going to close the terminal, change the port and restart myself manually. Okay, restart has been completed. Let's go to the DreamBooth, select model, load settings, just quickly verify settings. I am unchecking this because it is usually problematic. Class page size is 2 and let's hit train. You can also generate classification images from text to image directly yourself. Cut the generated images and put them into a new folder. Okay, we got error once again. This is a memory error actually. When we check the command line interface, we can see the memory error. So looks like our only option is class batch size 1. Let's click train. Okay, it is working. However, this will be very slow. So what am I going to do is I will enable xformers, manually generate from text to image and use them as classification images, which will save our time significantly. So follow me, how am I doing? First, I will just terminate the terminal. From here, I will add --xformers, change the port and restart, Python relauncher.py. I would also clear text to images tab so you can directly use it. So I will just rename it. It will generate a new folder for me, and new app is started with xformers. Let's open it. So our class prompt is photo of man. I am typing photo of man. I am going to set the sampling steps as 30, which is a decent enough, and I am leaving all other options are same. And I will use batch size as 8. And how many images total do you need? Let's say for per training image 50 images. Since I have 9 images, I am going to generate 480 images. Therefore I need to set this minimum 57 and then hit generate, and let's see if we will get out of memory error. And you see from text to image tab we are not getting out of memory error even when the batch size is 8. So it will very quickly generate all of these images for us much faster than using the classification images that is being generated in the DreamBooth. If you wonder why it is generating images like this or why we are using these kind of images, In this video, I am explaining all of them. So we are keeping the underlying contextual data of the model. You could also use more beautiful images in your classification training dataset. However, it would break your model contextual meaning, so your model would become more biased to the images that you have used. Also, your face would be biased to the images that you use. With this methodology, we are using the underlying contextual knowledge of the model and we are trying to keep it as much as possible. However, this is up to you. So if you use all handsome images, all full colored, professional, real images, then your model would become more biased to them. This is how custom models are usually made. They are being cooked to those kind of images. So whatever you type, you are getting beautiful images because all of the other underlying contextual data of the model is lost during the training. Actually, according to the ControlNet developer, SD 2.1 version is inferior to the SD 1.5 due to the used clip. You can read this with pausing the video right now. Okay, looks like our 1.5 version experiment has ended. Let's go to the outputs, and in here there are text to image grids, and you see there is a grid file 35 megabytes. Let's open it. Actually, I will download this, and there is also 228 megabytes. So for downloading, let's use the RunPodCTL. I am going to open a new command line in here. RunPodCTL, send text to image grids, hit enter, and it will generate download link for us. Go to the folder where you want to download. I will download inside in here, type cmd, copy paste the link like this. So it is going to download 265 megabyte grid output. This is much faster than downloading from the Jupyter notebook. Okay, the grid images are downloaded, and in here this is the newest grid image that is generated. It is over 200 megabytes. It is over 35,000 pixels, and now we are able to compare different checkpoints with different prompt emphasis and with different CFG scale. So this is for CFG scale 7. These are the checkpoints and these are the prompt emphasis. Let's find the best one that we like and that is similar to us. You see, these faces are not like me, but in here I am seeing faces like me. So with prompt strength 1.4, in these checkpoints I am starting to get similar face like to me. I think this one is very similar to me. So with prompt strength 1.4 for CFG scale 7 and for checkpoint 3000 steps. Yeah, I like it. So you should also compare for yourself, and after prompt strength 1.4 the image becomes very bad. So let's also look at the other CFG scales and checkpoints. Okay, now I will show you slowly what is happening from CFG scale 10 to 7, and this is the prompt strength 1.4. This is how the images are changing. This would of course depend on your training dataset, how it is trained, and I can see that they are not very good at all because we also didn't use any negative prompts. Our aim here is finding the sweet spot of prompt strength and the checkpoint and the CFG possibly. Okay, I think this model is still not trained enough because with only 1.4 strength and in the 3200 steps it is providing the best. So therefore I will train this model even further with more steps and then do another experiment. However, currently we could use 1.4 strength with checkpoint 3200. I suggest you to test no half and precision full training for ST 1.5 version as well without xformers and compare whether it is learning better or not. Because of the used graphic card, this could be making a difference, and you can test use 8-bit ADEM or not. You can test mixed precision no versus FP16 and BF16. So these all things could improve your training success rate, you should experiment with them, and currently I do not have time to test all of them. I am showing some of the settings that are widely used, but you should also experiment with them, like options like this, or like this, or like this, or like this. Now I will show you how to download custom models from CivitAI.com and use them in your RunPod IO. So I am going to show example of Protogen X3.4. Right click download latest, copy link, go to your RunPod IO interface, Jupyter interface, and in here go to the folder where the model files are downloaded. So in this folder, which is model Stable Diffusion, where you are supposed to put your model files, open a new launcher, open launcher, type wget, paste the link and hit enter, and it will start downloading the model file. So you see 5.6 gigabytes, and you see there are no more space left on my hard drive. What I need to do is I will delete some of the models. So I am going to delete some of the training checkpoints. They are located inside models, inside Stable Diffusion, inside my training folder, and in here I am going to delete some of them. You can also do a directory delete, right click and delete. You can also select them and hit delete button on your keyboard. Okay, I think we got now sufficient space, so I will just rerun the prompt. So to open back the latest executed command, I just hit up arrow and hit enter, and now it will start downloading. Currently it will be downloaded in this folder where we had opened this terminal. Let's go back to there, models, Stable Diffusion, and now this file is being downloaded with the name of 4048. Then I will rename it. Meanwhile, 2.1 version classification regularization images are still being generated. We can see the process in the terminal of it. You see it has generated over 160 images so far. Okay, it is downloading the custom model file with 50 megabytes per second. You can also upload those files from your computer, or you can download from Hugging Face, as I have shown you already. So this is how you can download files fast on your pod. Okay, the file has been downloaded and save it as 4048. I will rename, right click, rename, and let's say Protogen X34. It is renamed. Then let's go back to our Stable Diffusion interface, click refresh folder. It is not appearing because the model file extension is not correct. Right click, and when renaming, add .ckpt to end of it like this, and then refresh again. Okay, now we see the model here. Let's test it. Okay, it didn't load even though I have selected. Let's look at the command line interface. Okay, it says that we should add disable safe unpickle because we have downloaded it like that. So I will add this to the command line arguments and restart like this. Let's also change the port. Just close all of the terminals. Okay, restart has been completed with disable safe unpickle. Let's open the interface. Okay, let's try with Protogen. Okay, we got error once again because when we download it, it is downloading safe tensors, not ckpt. Therefore, we have to rename it once again into safe tensors, .safe tensors, like this. And try again. Let's hit refresh. Now there is safe tensors. Okay, it is loaded. Let's test it. And Protogen is working as expected. You see awesome, intricate, fantastic castle in a forest. And this is what I got. Let's run again. And yes, this is definitely Protogen. Let me run it on 1.5 version official as well. Okay, 1.5 version is loaded, and this is the result on 1.5 version official. So this is how you can use custom models on RunPod IO. 2.1 image generation is still going on. Now I will show you how to do textual inversion training. To do that, let's go to the train tab. By the way, before doing that, let's go to the settings, and in here in training, Move via and clip to RAM when training if possible. You can pick this option to reduce VRAM usage. You can also turn on pin memory for data loader. Makes training slightly faster but it can increase memory usage. You can also pick this depending on your machine's RAM memory. However, since we have 24 GB, I am not going to pick them. So let's give a name as test. Initialization text is none. Number of vectors is 2. You can watch my excellent how to do Stable Diffusion Textual Inversion video. I am explaining in great details in this video, and you can learn many of the things related to the textual inversion from this video. Hit create embedding and it is already created. Let's go to the train tab, pick the embedding. We also need to set dataset directory. So our dataset directory is like this. We don't need classification images for textual inversion training. You can reduce the learning rate or leave it as default. You can test it. Okay, we need a style file word for textual inversion. When you watch this video, you will understand it better. So this text file is located inside Stable Diffusions, inside textual inversion templates. In here, I'm going to edit the none as name. You need this, otherwise it won't work. This is the name of the textual inversion. This is basically going to use the unique tokens that it generates. So I'm going to pick none from here. My width and height are 512 pixels. Max number of steps, you can leave it as this because it will generate pretty small files, but since we are already using a lot of space, I will delete my older checkpoints from DreamBooth, Stable Diffusion Web UI, inside models, inside Stable Diffusion, and inside test2 folder. Okay, for selecting, hit left shift key, select first, then go to the very bottom. While pressing shift key, hit here, it will select all of them. Then while hitting control button, left control, unpick the ones that you don't want to delete, right click and hit delete. It will delete all these files and open a space for me. Okay, now we are ready. I want to check checkpoints for every 10 epochs. How many training images I have? I have 9 training images. Therefore 1 epoch means 9 steps. 5 epochs means 45 steps. So for every 5 epoch I am going to make save. I don't need this and I will pick deterministic. This is the best option and we are ready. Just click hit train embedding. Okay, it has started training. By the way, currently xformers is enabled. Therefore I will disable it and restart again because there is a bug as I have just shown and it is preventing good training. Also in settings, this is unchecked, use cross attention optimizations, but still it could be using it due to a bug. So best thing is just disabling the xformers and restarting the training. However, looks like learning right now, I think. So probably there is no bug for this one, unlike the DreamBooth. The loss rate is also pretty low and it is pretty fast. Okay, it already started learning my face, not very good, but there is a resemblance as you can see, and it is really fast. The number of steps it is taking really fast. This is how fast it is. You see, training textual inversion, epochs, training speed, the IT per second, and it is learning. However, which one will be best is needs to be checked from text to image tab from XY plot, and as you can see it is learning. So all these samples are being saved inside. Let's go to the Stable Diffusion Web UI folder. Inside here, textual inversion. Inside here you will see the training date, and inside here the name of the textual inversion training. Inside here images, and these are the images named with the epoch number. You can check them like this, or you can download them and check all of them. Okay, 2700 steps looks a little bit decent. It is actually equal to 300 epochs. Maybe it may get better over time, or we may need to use more vector count, but since I am just trying to explain, I will use this and show you how you can use this checkpoint in your queries in your text to image tab. First I will cancel the training, This one also looks like a decent one. Hit interrupt. Yeah, 3240 also looking decent. So it may get even better over time as we do more training, but I don't have too much time. Okay, so to be able to use these embeddings, first we need to copy the generated PT file, which is the checkpoint. To do that, go to the textual inversion inside your main folder, go to the date that you did training, go to the training name, go to the embeddings, and in here you will see the .pt files. Pick the checkpoints that you want to test, right click, copy, then go back to the main installation folder, and in here you will see embeddings folder and paste them there like this. So it is pasted now here. So to activate this textual inversion, we are going to type it like this. By the way, there is one very important thing. When you do training, it will train based on the model selected here. Therefore, this will be most compatible with this selected model, and just hit generate. And you see our face is generated, trained subject. Now we can try stylizing. Okay, I did a simple test of some intricate 3D ArtStation cinematic lightning and generated batch size as 8. And these are the generated images. So with better prompting, it should be possible to get better results. You can do same training on Protogen or any other custom model as well. Just check it from here, make a new embedding and do training. The textual inversion training works pretty decent on custom models as well. However, custom models are not working very well with DreamBooth training. Okay, so our image generation for classification dataset for SD 2.1 is completed. Now we will put them into the correct folder. So all of the images are now generated inside this folder. How am I gonna do that? I will right click, cut, then I will go to the workspace, right click, paste, and then I will rename as class 768 version 2 like this. Then I will go to the DreamBooth tab. I will open my test, load settings, go to the settings, and in here I will set the concept, the classification dataset directory as class 768 version 2, and now I have 50 images for per instance. Okay, everything else is same. Just save settings and hit train, and let's see if we will get out of memory error or not. So it is pre-processing class images. We can see the command line interface. Okay, so it looks like the Gradio is killed or our web app, therefore we need to restart it. By the way, we also need to disable xformers, otherwise it won't work for training. So I am disabling xformers, saving, closing all of the terminals, and starting a new instance of the web UI. Okay, restart is done. You see, these are the command line arguments that I have used to start 2.1 version web UI. Let's open it. Go to the DreamBooth, select model, click load settings. Just verify settings quickly if they are correct or not. Okay, all looking good. And let's click train to see how it works. Okay, pre-processing class. Let's also see the CMD window from here. Okay, you see it says nothing to generate because we already have sufficient number of classification images in our folder, 456, and we need 450 images. So it is caching right now. Okay, after caching, it is killed once again and trying to relaunch. Okay, we got out of memory error, so we need to enable some more of the memory optimization, and I already unchecked the EMA. Therefore, looks like we need some more optimization. So I will pick FP16, but we are not using mixed precision, so it is probably being ignored. What else we can do for more optimization? Gradient checkpointing. Yes, we can do this. And let's save settings, load settings, and hit train once again. Okay, looks like I had to refresh, load settings, hit train. Okay, yeah, it says that change in precision detected. Please restart web UI entirely to use new precision. Alright, so we will restart it. Okay, restart is done. Let's go to DreamBooth, select model, load settings, and now gradient checkpointing enabled. use 8-bit ADM, FP16, memory attention default, cache latents, and let's see if we will get any error or not. Okay, training started this time. I hope we don't get any error during preview generation because it also uses GPU, and we can see our GPU is being used at 95% already. You can also see other utilization parameters here, volume, container, and this is my other running pod, and this is how much I have spent and how much I am spending. So now I will show you how to install ControlNet on SD 1.5 version. If you don't know what is ControlNet and how to install and use it, I already have a great tutorial on my channel. So this is the extension that we are going to install. Copy the extension URL. You can also find this in the description. Go to the extension tabs, go to the install from URL, copy paste it and click install. Then once it is installed, go to the install tab, apply and restart UI. After we click it, unfortunately the Gradio is died again, so I will relaunch it. And since I am not going to do any training, I am enabling xformers once again because it will speed up my image generation. Okay, after restart, go to the text to image tab, and in the bottom you should see ControlNet like this. Now we need to download ControlNet model, which is hosted on Hugging Face. In here, go to the files and versions and just download which model that you want to use because each model files are like 5 GB. I'm going to show Scribble as an example. All others are same, exactly same. And when you watch this video, you will learn more about them. Okay, right click the download button, copy link path, go to your RunPod. So these files will be put inside another folder. Go to the extensions. Go to the SD Web UI ControlNet, go to the models. We are going to put them inside here. So in here, I will open new launcher, open terminal, wget and copy paste the link. And you see it has started downloading file from Hugging Face with an incredible speed. Meanwhile, I will show something else, how you can download your trained models into your computer. So to download your trained DreamBooth model, go to the models, go to the Stable Diffusion, go to the training, and let's say you want to download this ckpt. You can right click and download, or you can use RunPodCTL as we already shown multiple times, but let's just show once again. RunPodCTL send the checkpoint file full name, not the directory, and it generated the download command like this. Go to the download folder where you want to download. So let's say I want to download here, open CMD, right click paste and hit enter, and that model file will be downloaded into your computer with a great speed like this. As you can see, it is downloading with 70 megabits per second, and my maximum internet is 100 megabits per second. So this will of course totally depend on how other users are currently using the pod network. Okay, meanwhile, ControlNet file is downloaded and saved in the folder. Let's verify it. Go to the extensions, SD Web UI ControlNet, inside models, I see the PTH file. Let's go back to the ControlNet, and in here, when we refresh models, we should see it. Yes, it is here, and there is also preprocessor. Then upload your file into this canvas that you want to use. I will do a scribble. I am going to use this file. Let's set the canvas with an height like this. Also set your target resolution. I will use the native resolution of the provided image, which is 866 and 684. Then type your prompt here, and you can use the any model from here. Let's use Protection model. So my prompt is Dragon Awesome Intricate Cinematic Art Station. Let's type some negative, love, bad, worse. Hit generate. Okay, we didn't get the output because we didn't enable the ControlNet. Don't forget that. And don't forget to check scribble mode, invert colors. And now it is the map it generated, and this is the output we got. So you can play with different prompts and different models and generate different images. It works pretty fast and pretty correct. Just watch this video to learn more. Actually, I have another ControlNet video as well, which is based on the native released scripts from the official author. You can also watch this video to learn even more about ControlNet. Our ST 2.1 version training is going on. However, it looks like there are some problems because generated image is not correct. Okay, I have done a lot of research and looks like there is no way to do ST 2.1 version 768 pixels training with DreamBooth without using xformers. I wanted to avoid xformers during training because it reduces the quality of the training. However, 24 GB VRAM is just not enough, so we need to downgrade the xformers version to 0.0.14. I already have an excellent tutorial video for that for Windows installation. So now I will show it on Unix on RunPod. Alternatively, you can go to the browse servers and in here you can deploy a RunPod with 48 GB VRAM or 40 GB VRAM. It is up to you, but they cost more. Therefore, we will just downgrade the xformers version. Now follow me very carefully to learn how to downgrade xformers on RunPod IO. First, close all of the running kernels and terminals. Then inside Python 3.10 folder, start a new terminal. First, we are going to run this command pip uninstall torquevision, paste it and hit yes and hit yes. Okay, it is uninstalled. Then we are going to run pip uninstall torque audio, paste it. Okay, it is done. Then we are going to use pip uninstall xformers, hit yes and it is done. You know, currently I am inside workspace VNV lib Python 3.10. The folder where you are currently located makes huge difference. Make sure that you are inside the same folder. You can also apply this to SD 1.5 version as well. It is just same thing. Then we are going to install torquevision. Just copy this and paste it and hit enter. Okay, I got error. It says that there is no space left on the device because currently we started with 5 GB space for runtime. Therefore, I will stop the pod like this. I will edit the disk space from click here, more actions, click edit pod, and in here increase the container disk size, save it, run it, start it, and reconnect to Jupyter Lab. Enter inside the same folder VNV lib Python 3.10, open terminal, and make sure that you run all of the commands once again to be sure. Pip uninstall, hit yes if they are installed once again, and pip uninstall torque audio, then pip uninstall xformers. Okay, it is done. Then we will install this one. As you can see, I have changed it because this is the one that is working. Copy paste and hit enter and it is going to install. So once the full version of 0.0.17 is released, it will work with DreamBooth. Currently this is a development version, as you can see, and it is installed. Now we are ready to run our web UI as usual, and it should support DreamBooth training with xformers. Before starting, I am going to edit xformers command line arguments minus xformers, and I am going to add back the full precision minus no half and minus precision full and minus no half via. Save it, run on a different port, shut down all of the terminals, start a new terminal, relaunch the web UI like this. Okay, so our application is now starting with 0.0.17.dev 448 version for xformers, and these are the torquevision diffusers and other versions. Okay, it is started. Now time to test whether it is working correctly or not for ST 2.1 DreamBooth training. Okay, I am loading my model, load settings, and in here let me show you quickly the latest settings. So let's make the amount of time to pause between epochs 0. I will say for every 20 epochs. I am unchecking gradient checkpointing. I will make learning rate as default. Actually, let's try it. Okay, photo of OHWX man by Tomer Hanukkah for sanity prompt, and in advanced tab, now this is important, I will use Emma And in the mixed precision, I am going to use FP16. Some cards also supports BF16, but to be sure, use FP16. And when you hover your mouse, it also says you that required when using xformers. And in here, I am going to use xformers. This is important. Cache latents. Okay, then go to the concepts tab. They are set. Everything is looking good. And in saving, generate a ckpt file when saving during training and hit train. By the way, we should have clicked save settings before, but I think it is automatically saved. If it doesn't work right away, just click save settings, then hit train. Okay, let's watch the terminal. I hope that we won't get any more out of memory error. Okay, it is killed, so I will test one more time. Refresh the Gradio, DreamBooth, select model, load settings. Now this time I will set gradient checkpointing because it looks like necessary. FP16, use EMA, and yes, everything is same. And let's try again with save settings, train. Okay, we got another error, so this time I won't use EMA. Refresh the interface, DreamBooth, model, load settings, uncheck gradient checkpointing and uncheck use EMA. This is significantly increasing the VRAM usage. Save settings, hit train. Okay, finally the training has started, and now time to wait and see how well it is learning and training. The Gradio is still responsive, that is very good, and it is using this much of GPU memory. So you see how much GPU memory usage the EMA is increasing when we check the EMA option. Meanwhile, SD 2.1 version training continues. I will explain what is fine-tuning with DreamBooth. Okay, before I show how to do fine-tuning, we got an error during the SD 2.1 version training at the 400 steps, which means when it is generating a ckpt from the 20th epoch checkpoint. Therefore, I will restart the training with one parameter change, load settings, and go to the settings tab and enable gradient checkpointing. The rest is same like this, so it should just work fine this time, I think. Save settings, hit train. Okay, this time we didn't get any error during SD 2.1 version training. We got sample, yes, somewhat similar. This is the first one at the 20th epoch, and we got our sanity prompt as well. This is the loss rate, which is very erratic, as you can see, and this is the VRAM usage like this. Now I can start showing you fine-tuning. I have opened my 1.5 version RunPod. So what is the difference of fine-tuning? In the fine-tuning, we are not going to use classification images, and we are going to use file words. Fine-tuning is basically using a lot of good images with proper captions and not using any classification images. The rest is same. So every one of the keywords, every one of the tokens in the captions of the images will be trained, and they will become like the images that you use for fine-tuning. First of all, we need to process image files and add captions to them. So go to the training tab, go to the preprocess images, set the source directory. I don't have a dataset for fine-tuning. A good dataset you need, a lot of images you need. So I will use my own pictures that I use it for training and set a destination like training captioned, and in here use bleep for caption. And if those images are not 512 and 512 pixels, if you are going to fine-tune SD 2.1 versions with 768 pixels, then you need to change this resolution as well. You can also crop them with autofocal point crop, but manually cropping them and preparing them is better. And then click preprocess. When the first time you run it, it will download the bleep model from internet. Okay, preprocessing has been completed. Now training captioned folder is generated. Now you see there are txt files named same as the image file. When you open them, you will see this captioning. So what does this mean? In the fine-tuning, all of these words, these tokens will be improved by the image they are same named. So all of these words will be improved towards this image. This is what is fine tuning. Let's say you want to improve castle images, then you should have good castle images, and inside their description you should have castle word. And if you want to associate those pictures with other words such as beautiful, intricate, high quality, then you should also put them. So put here whatever the words that you want to improve in your model with related to the picture they are associated with, and then once you prepared good captions and images inside your folder, copy the path of the new folder, go back to your DreamBooth tab and make this setup like this in concepts, workspace, training captioned, data directory. Now this is important. In the prompt, just type file words and nothing else. This means that whenever it is training that particular image, it will load whatever is written inside here and replace instance prompt with it. That's it. So this will be equal to this prompt for this particular image that is going to train. In class prompt, we are not using any classifications or class prompt. In the sample prompt, you can use the file words to see what kind of images it is generating, and make sure that class images per instance is 0, because we don't want to try to keep the previous context of the model. We want its underlying context, latent space to be improved, and that's it. Everything else is same. So for fine tuning, you need a lot of good images, good quality images with good captions. Those captions will be improved. It will also improve the unit of the model, so it will become overall better and overall cooked, we can say, because if you show less number of images than it was trained on, it will lose a lot of the contextual knowledge it has. Therefore, these cooked custom models are not good to train your faces on them, because they don't have as much as information as these 1.5 produced CKPT have. For example, this model was trained on 5 billion images as far as I know. However, those custom models may be trained on 1000 images, maybe 10,000 images. So their unit has become like those 10,000 images instead of being trained on 5 billion images. That is why they are so good, but they have much lesser knowledge in their underlying context, in their latent space. So this is basically fine-tuning, how it is done. If you want to be exactly same as Stable Diffusion training, that the official training, you can also remove text encoder training with setting this parameter as 0. So with this way, the tokens won't be improved, only unit will be improved. However, you don't want that for fine tuning. This is more like using hundreds, thousands of images and training from scratch your model. So you should keep it perhaps like 1 and train unit as well. So you will train both text encoder and the unit and improve all of those keywords together. Hopefully I will make another very technical video about how training works, what is unit, what is text encoder, how they are being changed during training, and it will explain a lot of the questions that are not very well answered in the community. So stay subscribed, open notifications to not miss it. So let's check out our 2.1 version training. Okay, our sanity prompt already looks like lost its stylizing ability, and the sample is not also looking very good. However, I have seen that it was learning, so let's open the directory. Okay, inside DreamBooth, inside samples, let's look at each one of the sample. So this is the 20 epoch. Yes, it has a resemblance, it is not very good. This is the 40 epoch, very minor resemblance. Let's check out the sanity prompt. The sanity prompt is much better. So this is somewhat similar to me, but stylized in Tomer Hanukkah style. So the sanity prompt of the 60 epoch is not good at all. It lost its stylizing. The sample is also not very related, but this is ST 2.1, so it is harder to train and obtain good images. So you see, this is the 80 epoch. This is almost as like me. Let me show you for comparison. With AD Epoch 2.1 version, it is started to learning my face very well. Let's check out the sanity prompt. However, sanity prompt also lost its ability to stylize, so our learning rate could be very high. Perhaps we should try half of it. Based on your training dataset, the learning rate may change. Number of steps, number of epochs that you need to do training may change. So it is up to you to do multiple trainings and compare how well they are working with X, Y, Z plots as I have shown. However, the training is working very well. It is learning the subject very well. So we managed to make it work very well for SD 2.1 version 768 model. Let me show you the parameters once again. So I will slowly scroll down and you will be able to see all of the settings. This totally depends on your learning rate and how many number of training images you use. You should also save multiple checkpoints during training and compare them. Batch size 1 and gradient accumulation 1. If you increase this, it will increase significantly your VRAM usage. Also, we can't say bigger batch size is better. It's a debated topic. Mini batches versus full batches. These two are checked, otherwise we are getting VRAM error on 24 GB. This is my current learning rate. This may be fast, so you may try half of it or even lower. This is the resolution. This is the sanity prompt to see how well it's stylized. So don't check EMA because you will get error, VRAM error even when using xformers. Use 8-bit ADEM, use FP16 to be sure that it is supported on your graphic card. Use xformers, cache latents, train unit, train text encoder, and these other things are just default. Okay, now I will show you how to install and run Kohya LoRa training, Kohya GUI on RunPod. To do that, we are going to use Kohya SS Linux branch. To do that, we are going to use Kohya SS Linux fork of the official repository of Kohya SS. This is modified to run on Linux. So first of all, we are going to clone the repository into our RunPod. So this is my 1.5 RunPod. I am inside workspace. I have closed everything. Open a new terminal. Copy paste the git clone command. It will clone into the Kohya SS Linux folder. Then move into the Kohya SS Linux. Type cd ko, type tab, hit enter. And now I am inside Kohya SS Linux. Then we will generate virtual environment folder with this command. Copy it, hit enter inside this folder. Okay, it is generated. Let's also move it in here. Now we will run the next command, which is for activating and entering inside that virtual folder. Actually, source vnv command, copy paste it, hit enter. Now you see vnv here. That means that currently actually we are running on the newly generated virtual environment folder. Next, we are going to install requirements. This is only one time necessary. The requirements file is located inside here, and currently we are also inside that folder, so it should work. The requirements installation may take some time. These installations will not affect your other installations because everything being installed here will be only installed inside this folder. Okay, we got an error that says no space left on the drive, so I will just close the RunPod with stop pod, and I will increase the container disk size to 10 GB. To do that, click here edit pod and run it once again. Start. Then click connect to Jupyter Lab. Okay, it is still getting launched, so be patient. Okay, notebook started once again, so I will just delete the vnv folder, rm -r vnv. So I will start from beginning, python -m vnv, then source command activate, then install command. It will install the requirements. Okay, all requirements have been installed. As author here noted, it requires Python 3.10 and it doesn't work on 3.11 since the RunPod runs on 3.10.9 for Stable Diffusion. It is just fine. Then we will set accelerate config. I am copying this, pasting in here we are still inside that VNV folder. So now it will ask us a bunch of questions. Select this machine, hit enter. Select no distributed, hit enter. Type no to this question, then type no to this question as well, and type no to this question as well, and type all for this question. And do you wish to use FP16 or BF16? Select FP16. It will speed up your training and also use lesser VRAM. Okay, and everything is ready. Then we are currently activated with source command, so we don't need to run this again. We will just run this command and it should start our GUI. Okay, it is running on localhost, so therefore we need to run it on shared link. To enable public Gradio link as we are using in Web UI, open the Kohya GUI.py, go to the interface launch tab here and add this, share true, save it and start it once again. So new terminal, open, first activate the VNV like this and just run this command. And now it has given us a Gradio link. When we run it, the famous Kohya GUI is loaded and ready to do training. The training with it is another topic and I won't cover it in this. Now I will stop my running RunPods, and when I stop with them, nothing will happen. They will just remain as they are. I can also start them without any GPU. So from here you can select 0 and you can start your RunPod to backup your data, to download your data without using any GPUs. So when you run them on CPU, the disk cost plus it uses $0.16 per hour. So it is still costing something. I think it is costing half of the original GPU price. However, sometimes you may not get a GPU, sometimes all of the GPUs may be full on the RunPod, so you will have to run it without a GPU. So this is how you start it without using any GPU. And there is also Terminate. When you hit Terminate, it will delete your RunPod permanently. I already said this, but I am saying it again. So do not hit Terminate button unless you are 100% sure, because it will delete everything on this RunPod, and until you terminate and delete your RunPod, it will continue using your credits. Currently I have 2 RunPods not running and it is using $0.056 per hour. So this is the cost of keeping these 2 RunPods on my account. And when I delete them, you will see this will get decreased. Let's delete first one with terminate pod. Okay, and now this should get decreased. Let's go to the my pods. Let's refresh. Okay, now you see currently it is decreasing $0.28 per hour. This is charged per minute, by the way, not per hour. And I will also delete this and it will become 0. And now my credits are remaining as they are until I start another pod. There is one final thing that I want to show you, Cloud Sync button here. So with Cloud Sync, you can synchronize your data in your server to these cloud services. And there is a great tutorial on the RunPod blog. I will share this link into the description as well. So you can read here and set up your cloud storage and set a synchronization with your RunPod, and everything generated in your RunPod will be synchronized with your cloud. Also, you can use the RunPodCTL that I have shown multiple times to download your data, to upload your data. It is up to you that how you want to use it. I think I have covered everything that I have mentioned in the beginning. I hope you have enjoyed. Please like, subscribe and leave a comment to this tutorial. Also join our Discord channel, ask any questions that you can't solve. Also please support us on Patreon. It is really important. The Patreon link and the Discord link will be in the comments and description. All of the links we have used in this video will be in the description. You can also find our Patreon page on our About tab of our YouTube channel. We have so far 26 patrons. I thank them a lot. Thank them very much. I hope you also become a Patreon. Hopefully see you in another awesome video. Thank you so much.